All right. Good morning, everybody. Hopefully, today's warm up is not as hard as yesterday's. We had to do something new yesterday, which makes it really hard. When you're learning something new, and especially some of the new, tougher things, um, it could be a challenge. Okay. And I appreciate those of you that were up to the challenge, and those of you that weren't quite up to it yesterday, hang in there, right? Don't stop trying, right? Uh, you're working hard, so eventually life will become easy, right? All right, go ahead and copy this down. Okay, and I'm going to go ahead and zoom in a little bit. So you copy the top half down first, the light on. It kind of looks blue, even though it's a white piece of paper. Copy all those down, and then I'll come back and I'll have you copy the proportions down when you're done, and then we'll go through it. Okay, now let's look at the proportions that you want to solve. And I'll have you pause and copy that down. Now, remember, when you solve this, the first step is to cross multiply. Okay? And then it's just like solving an algebra equation. So if C over 3 equals 1200 over 8, then I can cross multiply, and C times 8 will equal 3 times 1200. If 6 over 5 is equal to 1500 over W, then W times 6 equals 5 times 1500. Okay, let you try that third one. Go ahead and copy that down after you press pause. Okay, now you want to go back to the top and start filling in answers. Get as far as you can. If you need a hint on one of them, raise your hand and ask your teacher. Okay, but you want to try to do all of them, and the ones you're stuck on, ask for hints, and keep doing that until we're out of time and ready to go over it. Okay, the key is for you to stretch here, right? You don't want to just stay continuing to always do problems you know how to do. Every once in a while, you want to be trying to do problems you don't know how to do so you can get stronger. Okay, all right, go ahead and press pause. All right, let's get some answers. Now, diamonds, what two numbers have a product of 49 and a sum of 14? Hopefully you recognize that was going to be 7 times 7. Now, who knows what this one's going to be? Product of 256, that's Mr. Daniel's favorite number, and a sum of 32. Hopefully you're figuring out that's 16 times 16. How about a product of 48 and a sum of 19? This is a tough one, right? Because I know 6 times 8 is 48, but 6 plus 8? That's not 19, right? 6 times 8 work, huh? Crazy. All right, that's going to be a pattern of that. And check this out. Remember, when you have a product, 6 times 8 equals 48, you can take half of one number and double the other, and you will get the same product. So 3 times 16 will also be 48, but guess what? 3 plus 16 is 19. Okay, so if you totally get stuck, right? The other thing you could do is just say, you know what? I'm stuck. I'm going to find all the factors of 48. Remember how to find all the factors of a number? Well, you always know 1 goes into it. 1 times 48. So 1 and 48 are factors. Okay, it's even, so I know 2 is going to go into it. How many times? Hopefully figure out 24. 4 plus 8 is how much? Right, 12. So 3 goes into 12, huh? So I know 3 is going to go into this, and we already figured that out. It's 16, right? Now, it's 2 times an even number, which means 4 is going to go into it. If it's 2 times an odd number, 4 won't go into it. Okay? So 4 times how much? Well, 4 dozen is 48 inches, right? 4 times 12. Does 5? No, 5 won't go into it. Again, 3 times an even number, which means 6 is going to go into it. And that's 6 times 8. Now, you see how these numbers get bigger and these numbers get smaller? There's nothing between 6 and 8 except for 7. And 7 doesn't fit into it. So I'm done checking. All of the factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. And I'm looking for the pair that add to 19. So if you're totally stuck, on one of these diamonds, that's what you can do. Go find all the factors. There aren't a lot of factors of 49. 1 times 49 and 7 times 7. That's it. So I'm looking for the pair that adds to 14. Boom. Okay. Don't act like you're helpless on these, even when I'm writing off the screen. All right. All right. What about this one? This was the stumper one. If you got this, you got to give yourself a cookie when you get home. 4 times 1 and 1/10. Whoops, I'm writing times. 1 and 1/10. Right? 4 ones and 4/10 is 4 4/10. Or you say 4 times 11 is 44. But I had to move the decimal over one spot there to pretend it was 11. So I had to go back one spot in my answer. When I add 4 plus 1 and 1/10, where's the decimal in the 4? Well, if there isn't one, it goes there, right? Remember, 4 equals 4.0. So now I line up the decimals when I add them, and look what I get. Okay? Anybody get all 4 of these? Good job. Good job. All right. Instead of saying to the second power, I could say one word. Do you know what it is? Squared. So what is 9 squared? It's 9 times 9, 81. Now, this way we're working backwards. What number squared equals 36? What number times itself is 36? 11 squared. It's not 111. It's not 110. It is 121. And the square root of 64 is, there's the snowman. 7 to the third power is not 21. It's 7 times 7. It's not 147. You take that 7 times 7, get your 49, and 49 times 7 equals 343. Now, I'll bet you guys saw this and said, oh, I can't do it. What number times itself is 4? What number times itself is 9? So 2/3 times 2/3 is 2 times 2 is 4. 3 times 3 is 9. Boom. That wasn't that hard. I'll bet some of you chickened out, though, huh? Yeah, don't be afraid to try. Don't be afraid to try. I'm going to try to stump you with some of these. Okay, but usually if I ask you to do something, I think that you're capable. 2 1/4 plus 3 1/3, I cannot add those until I get a common denominator. Now, what number do 4 and 3 both go into? Remember, if the numbers are right next to each other, like 3 and 4, or 5 and 6, or 2 and 3, or 99 and 100, the smallest number they both go into is the product of those two numbers. I have to multiply. 3 times 4 is 12. So 12 is the smallest number. I did 4 times 3. I got to go 1 times 3. 1/4 is the same as 3 twelfths. I did 3 times 4 to get 12. I got to go 1 times 4. And now I have 3 twelfths and 4 twelfths is 7 twelfths. And 2 and 3 is 5. Okay? All right. 12 and 2/5 minus 3 and 1/2. Same idea here. I got to get a common denominator. And now we're going to tenths. Okay? So I got to rewrite. All right, you guys don't know, but that little pause that you guys had ended up being like a 45-minute thing with me talking to a couple teachers and having a meeting with Miss Teichman and Miss Hong. So here we are. We're back. All right. We're trying to figure out how to subtract fractions, mixed numbers, and we have to figure out to change the denominators. We're changing it to the tenths, and 1/2 is how many tenths? Well, you know it's 5, but how do we get that to make sure? We did 2 times 5, so I have to go 1 times 5. Right? And 2/5 is how many tenths? Well, here I did 5 times 2, so I have to go 2 times 2, and that's 4. So I have 4 tenths, and I'm going to take away 5 tenths. Uh-oh, I can't do that. I need some more tenths. I'm going to borrow, and remember, I cross that out, make that 11, and I'm borrowing 1 whole because I need more tenths. How many tenths can I get? 10. How many do I already have? 4. And this is the one situation when you borrow with mixed numbers where you can put a 1 in front of the other, that digit, right? Because 10 plus 4 is 1, 4. Right? But I don't want you to do that when you borrow anything else. In fact, that was probably dumb of me to make that assignment like that, right? Because you can do it wrong, just out of habit putting that 1 there. And I want to teach you, what are you really doing there? So really you're borrowing 10 tenths. 10 tenths plus 4 tenths is 14. Now I can say 14 minus 5 is 9, and 11 minus 3 is 8. Okay? All right. Now, the easiest problem of the entire warm-up, right? Multiplying fractions. It's what? 3 times 2 is 6. 7 times 5 is 35. Boom. Mic drop. I'm out of here. No. All right. Next one, right? Don't you love that? All right. On this one, we can do this different ways. 2.5, 3 2/5. You can use a generic rectangle if you want, right? 2.5, 3 2/5, right? And you could say 2 times 3 is 6. 2 times 2/5 is 4/5. 1/2 times 3 is 3/2, or 1 1/2. And 1/2 times 2/5 equals 2/10, which simplifies to 1/5. Okay, now I have 6 plus 1.5 is 7 1/2. And 4/5 and 1/5 is 5/5. Now, don't go changing denominators to add this. Look at 5/5. What is that? 1 whole. So this ends up being 8 1/2. Right? Now let's see. The other way of doing this is what I do is the C method. Right? And I change both of these fractions to improper fractions, mixed numbers to improper fractions. 2 times 2 is 4, plus 1 is 5. 3 times 5 is 15, plus 2 is 17. And before I start multiplying, does anybody recognize how you can cross cancel and make this easy? 5 goes into the top once and goes into the bottom once. Now I have 1 times 17 and 2 times 1, and I just have to divide the bottom into the top. Okay, remember, as Teichmann says, you can just kick that over with a karate kick. It falls over. You got the 2 there, the line there to 17. All you got to do, or think, divide the bottom into the top. 2 goes into 17 8 times. 8 times 2 is 16. Subtract. My remainder goes on top. My divisor on the bottom. It's 8 1/2, 8 1/2. Got the same answer. Must have done it right. Okay. All right, 8 1/2. Now, 8 divided by 3/4. I know how to divide fractions because Miss Nortz taught us how to smell my feet. Can I make 8 a fraction? Yeah, watch this. Watch carefully. Get ready to take notes. Boom, boom. All I got to do is put a 1 under it. And then you're smelling my feet, right? Remember the SMF? The first number stays the same. Leave it the same. It's easier if you make it the same, right? And instead of dividing, I'm going to multiply y, because multiplying fractions is easy. And that F does not stand for feet or flowers. It stands for flip. I'm going to flip over that 3/4 to 4/3. Now I multiply across the top, 32, across the bottom, 3. I just have to divide the bottom into the top. 3 into 32. Let's do that on the back. Got more room. 3 goes into 30 10 times, right? My remainder goes on top. Divisor on the bottom. 10 2/3. Okay? 10 2/3. Let's go put that right there. All right. How about 3/7 of 4 2/5? Well, what does that mean? Boom. All right. Now let's go ahead and use the C method on this. 20 plus 2 is 22. 3/7 times 22/5. 3 times 22 is 66 over 35. 35 times 2 is 70, right? So this is going to be more than 1, but not that much more than 1. 66 minus 35. I keep tilting that paper. Sorry, you guys. 31. So this is going to be 1 31 35ths. Okay. All right. The tough problems. Solve these proportions. Remember, you cross multiply. So C over 3 equals 1200 over 8. I cross multiply. C times 8 equals 3 times 1200. 3 times 12 is 36, so this is 3,600. And how do I get rid of a times 8? Remember, my goal is to isolate the variable, find out what C is. Well, to get rid of a times 8, I do the opposite of times 8. That's also called the inverse operation. What's the opposite of times 8? Divided by 8. But I had an equation. It was in perfect balance. And then I just divided this side by 8, so it's not in perfect balance unless I do what? Unless I do what? Do the same thing to the other side. These two things cancel each other out. All that's left over here is C, and I just have to figure out how many times 8 goes into 3,600. Let's go up here and divide. 8 times 4 is 32. Get a remainder of 4. Bring down the next one. 8 goes into 40 5 times. That's a perfect fit. One more 0 goes into that 0 times, so 450. Boom. Okay? Same idea here. 5 times 1,500, you can figure it out. It's 7,500. I have to get rid of a times 6, okay, because I want the W by itself down here. The opposite of times 6 is divided by 6. If I do it to one side, got to do the same thing to the other side. They cancel each other out there. All that's left is W, and on this side I have 7,500 divided by 6. How many times does 6 go into 7,500? Well, it goes into 7 one time. Write down the next number, goes into 15 twice. Write down the next number, goes into 30 5 times, and that's a perfect fit. So it's going to be 1,250. Okay, and I let you set this one up. Now, again, I usually try to get the one with the letter first, the variable, and I usually put the variable first. So instead of writing 2 times L, I'm going to write L times 2. And that equals 24 times 25. Now I'm going to do 24 times 25 in my head. You know how? I know 4 25s is 100. All right, 4 quarters is $1. How many 4s fit into 24? 6. So this is actually going to be 600. Now again, I got to get rid of a times 2. How do you get rid of a times 2? Well, it's the opposite, divided by 2. If I do it to one side, you know the drill. Do the same thing to the other side. Okay, let's get that equal sign back in there. And again, times 2 divided by 2, they cancel each other out. I just have to figure out what's 600 divided by 2. And some of you can do that in your head. What's half of 600? 300. Okay. Now, I know this warm-up was a little longer than normal, but wasn't as bad as the last two, huh? And check this out. These last 3 problems, the hardest problems we just did, that C is to 3 like 1,200 is to 8, right? You see that? And that 6 is to 5, like 1,500 is to W. Well, tonight's homework, okay, we're doing word problems with proportions. And check this out. 1,200 is to 8, like 3 is to what? Boom. Talking about calories, right? And ounces of hot fudge. 6 to 5 is 1,500 to W. Well, guess what? We're talking about 6 to 5 and 1,500 and women. That's the W. Okay. And same thing here as last one. Okay. 2 to 25, 24 to what? 2 to 25, 24 to. So I set these last 3 up for you. If you're still watching the warm up, like you should, hopefully, well, then these 3 problems are done for you. Okay. Now you got to write them on your paper. Then you take a picture when you turn this in. Okay. But working hard on that warm up makes the homework easy. Okay. All right, you guys. I hope you have a great day and a great weekend. Okay.